Okay, so proving identities. So we have this given, so we need to prove that this given is identity. So these are the steps in proving identities. So first, work on the complicated side. Now, since on this given, this is the complicated side, so we're going to work on this side, then change all functions to sine and cosine. So if there is tangent, change tangent to sine over cosine. If there is cotangent, change that to cosine over sine. And if there is secant, change that to 1 over cosine. And for cosecant, that's 1 over sine. So we need to change everything to sine and cosine. Now, since we're going to work on this side and there is tangent, then change this tangent to sine over cosine. So therefore, this tangent is equal to sine x over cosine x. Then bring down the sine x. That's sine x plus, then bring down this cosine x. And take note, this is our goal, to make this equation equal to secant x. Then do the given mathematical operation. So first, simplify this sine x over cosine x times sine x. Now, in multiplication of fractions, so if we have 3 over 2 times 4, and this 4, that's the same as 4 over 1. So the rule for multiplication of fractions, so multiply the numerator and the numerator, that's 12, and then multiply this denominator. So in this case, we have this over 1. So therefore, sine x times sine x, that's sine squared x. Then over, then cosine times 1 over cosine x, then plus this cosine x. So just bring down this cosine x. Now take note also that this sine squared x is not equal to sine x squared, because this sine squared x, that's sine x times sine x, and this sine x squared the same as sine x times x. So therefore, the sine squared x is not equal to sine squared x. Then you simplify. So for addition of fraction, we need to find the LCD. So the LCD is cosine x. So cosine x divided by cosine x, that's 1 times sine squared x, and that's sine squared x. Then plus, we have this over 1. So cosine x divided by 1, that's cosine x times cosine x, and that's cosine squared x. Then we have an identity for this equation, that's sine squared plus cosine squared, and that's equal to 1. So therefore, this equation now becomes 1 over cosine x, because this sine squared plus cosine squared, and that's equal to 1 using this identity. Then this 1 over cosine from this figure to get the different fundamental identities. So this one is cosine, this is a secant. So therefore, 1 over cosine, and that's equal to secant x. So this one is equal to secant x. So we have now equal function.